In this lesson, we will be learning what is called partial fraction decomposition. Basically, we're going to learn how to take apart a fraction and see where it came from. But before we do that, we're going to go back and review adding two fractions, or adding rational expressions with unlike denominators. For example, if we have two fractions or two rational expressions with unlike denominators, we would first have to find what was called the least common denominator, which in this case is x plus 1 and x minus 3. Then we would have to ask ourselves, what would I need to multiply this fraction by to make it have that denominator? And of course you would say, well, I would need to multiply it by x minus 3 over x minus 3. And then this one I would need to multiply by x plus 1. Then we would distribute and collect like terms. And that is adding rational expressions. That's what we did a few years ago. Today, we're going to take this fraction and decompose it, as in find out which fractions were added together to arrive at that fraction, meaning we're going to go backwards and figure out how could we find out where it came from. We're going to look at 4 different types. The first one is the easiest, where you have non-repeated linear factors in the denominator. Then we're going to go through repeated linear factors, and then we're going to look at non-repeated irreducible quadratic factors, and yes, repeated irreducible quadratic factors. The first is the easiest, and thankfully it is also the most commonly used. So let's go through those steps. What are non-repeated linear factors? You're going to look at the denominator and we're going to factor it. So step 1 is to factor the denominator. So we have 4x minus 8. How do you factor that denominator? It's going to be x plus 1 times x minus 3. Now you should be going, well, this is the fraction we just did. So yes, we should know where 4x minus 8 comes from the very first thing. Let's see if we can get there. Let's go back to these words, non-repeated linear factors. Those are linear because x is to the first degree, and of course they're different, so they're not repeated. How are we going to set this up? Well, right here it says we're going to take the original fraction, which is 4x minus 8 over x plus 1 times x minus 3, and we're going to say, well, this equals to two fractions, some constants a and b over our two, in this case, linear factors. So that was step 2. We're going to set up the equation. Step 3, we're going to multiply the equation by the original denominator, which is that least common denominator, to get rid of the fractions. So if I multiply this whole thing by x plus 1 times x minus 3, what's going to happen? That's going to cancel out. Here, the x plus 1's would cancel, but the x minus 3's would stay. And on this one, the x minus 3 would cancel, and the x plus 1 would stay. So now you have no fractions. Now step 4. Our goal is to solve for a and b. What were those two constants? We're going to take this equation and we're going to let x be what's called convenient values. And the most convenient values is to look back here and say what would make those equal to 0. So we're going to let x plus 1 equals to 0, or in other words, we're going to let x equal to negative 1. And we're going to plug that back into that equation. So everywhere there's an x, we're putting a negative 1. And since we let that equal to 0, at some point we're going to get a 0, and some constant's going to go away in our equation. So we have negative 12 equals a times negative 4, so a is positive 3. We now have a, now we need to find b. So we're going to let x minus 3 equal to 0, this other denominator, So let's let x equal to 3. And again, we're going to come back up here to our equation and put in 3 everywhere there is an x. And again, you can see that that goes to 0. And so we have 12 minus 8, which is 4, and b times 4. So b is equal to 1. So now we know a and b. I'm going to come back to our equation. So 4x minus 8 over x plus 1 times x minus 3 equal to a plus b. And if you look at that very first thing we did, we added these two fractions and we got that. Now we've decomposed it, we've gone backwards. Let's look at the second example. The first thing you need to do is to factor the denominator. That way you will know what kind of factors you have. Are they linear? Are they repeated? And then go from there. So the first thing I see is a GCF of an x, and then I see a trinomial that I can factor further. So that looks like x minus maybe 4 times x plus 2. Checking that? Yes. Now look at the denominator. I have 1, 2, 3 linear factors, meaning x is to the first power. They're not repeated. So how do I need to set up that equation? Since I have 3 linear factors, I need 3 fractions. A, B, and C, constants. Now notice constants are really x to the 0 power, and linear is x to the first power. So you always want that numerator to be 1 degree less. That's going to become important later on when we get to those quadratics. Now we put these constants over our individual factors, and that's our equation. The next thing we need to do is get rid of the fractions by multiplying by that original denominator. So that's going to leave us 3. The x's would cancel, and that would leave me x minus 4 times x plus 2. On the next one, the x minus 4's would cancel, and it would leave me this. And then here, the x plus 2's would cancel. There. Now I need to solve for my a, b, and c, convenient values. Come back up here to my denominators and let those be 0. Here's my equation. Everywhere there is an x, I'm going to put in 0. And that's going to become 0, so it really doesn't matter about that part. Same thing here. Because everywhere there was an x, that is going to become 0 when I put in 0 here. So I have 3 equals a times negative 8 plus 0. So I have a equals negative 3/8. So that's one constant. Now I'm going to let x minus 4 equal to 0, or x is equal to 4. And again, coming back up here, so I have 3 equals a times 4 minus 4. I know that's 0 because since I'm using my x minus 4, everywhere there is an x minus 4, that's going to be 0. So it really doesn't matter about the x plus 2. So I have b times 4 plus 2 plus c, and that's going to be 0 because when I put in 4 right there, 4 minus 4 is going to be 0. So I have 0 here, 0 here. I have 3 equals b times, what is that, 4 times 6, which is 24. So b is going to be 3/24. So b is going to be 1/8. My last one is going to be c. So let's see, what's my last factor? So I have x plus 2 is equal to 0, so x is negative 2. That means every place there is an x plus 2, those are going to be 0. So I'm going to have 3 equals a is going to be 0. I'm going to have b times 0 but c is going to be times negative 2 minus 4, let's see, that's negative 2 times negative 6, that's positive 12. So c equals 3 over 12, so c is 1/4. So I have my three constants, and if you stop right there, I would give you full credit. But really what we want to do is rewrite that fraction into those individual fractions. So I have decomposed 3 over x times x minus 4 times x plus 2. What did that equal to? I believe that was over x, plus b, and b is 1/8, and that was over x minus 4, plus c over x plus 2. And you could leave it like that. Again, you could stop with just solving for the constants. You can rewrite the fractions like that, but that's going to be ugly. How most people would write this is negative 3 over 8x, bringing that into the denominator, plus 1 over 8 times x minus 4, again bringing that into the denominator, plus 1 times 4 times x plus 2. That just looks a little bit nicer. So again, you could actually check your work by taking these three fractions, adding them together by finding a least common denominator, collecting like terms, and you should get back what you started out with.